Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're joined by Brian Moses. How you doing, Brian?
Not too bad.
Awesome. Yeah, I was just speaking off there, just saying thank you for taking the time to come on the show. Just for background for the actual audience. So I've been really interested, probably about the last couple of months, just looking into maybe kind of upgrading my home server setup. At the moment, I've got a very crooked, slow, Atom-based nettop with an old Drobo hooked up to it. And that's kind of, you know, dealing with all my media set up, my Plex set up and things like that. And I was thinking, maybe it'd be time for me to maybe invest and actually look properly into hardware and stuff. Kind of transitioned over from being a custom PC builder back when I was like teenager to now a Mac guy. So really, we don't get to deal with any of the fun hardware stuff. So, you know, it's kind of foraying back into that. And one of the blogs actually that came up really highly was yours, Brian. And I've got to say, you pump out some amazing material.
Thank you. Thank you very much.
I thought it'd be really great to have you on the show and kind of demystify a lot of this stuff, because I think primarily our audience on this show is very much with software people, and I think there's a whole other world of the hardware and just, you know, deciding on hardware, and it's all really exciting, interesting stuff. And like I said, you know, just a minute ago, like your blog, you know, you kind of go through these bits and you really do lay it out really well, like your decision making and thought processes and what you choose. I'm just wondering, kind of like, what got you into computers and like in particular like NAS builds?
Well, I got into computers ages ago when my folks raided my college fund to buy an Apple IIe. So my PC love goes, you know, way back into the early 80s. But in particular, the network attached storage builds that came up. This has got to be about 5 or 6 years ago. I decided that, you know, we had enough computers here at the house that I wanted to start backing everything up locally. And I was going to do that, you know, just by throwing together a little NAS box. And I went out on Google and, you know, punched in DIY NAS. And all of the search results were frustrating to read. They were forum posts that were, you know, 18 pages in. And none of it was very helpful. And I'd had a blog at the time, but I wasn't doing very much with it. And my buddy Pat said, well, if you're frustrated with the search results and you can't find the content that you're looking for, why don't you write what you're looking for? And that's what I did. And what we found is on Google, I went almost straight up to the top of the search results. And as a result, you know, I've started doing these on a yearly basis.
I completely agree with what you're saying there, because until I found your blog, a lot of it is kind of going through forums, and you may find a nice snippet, interesting bit, a nugget out of like a forum post thread that, you know, goes way back, but it doesn't really, you know, there's no kind of story to it. There's like maybe bits and bobs. You're looking for a CPU, so you're going to that forum and you're going that post there, and then you have to go and search for other bits. But as I say, yours kind of congregates all that and aggregates it all and kind of into a nice, you know, story about building one, as opposed to foraying out. Have you always been into like the custom PC builds and things like that?
Yeah, pretty much. I mean, I guess a couple of years ago I was in a laptop phase. So, you know, it's like the MacBook or the Apple stuff. You don't get to do a whole lot with the hardware. You buy a laptop, that's what it is, until you get a different laptop. But yeah, I mean, I've been building PCs, I mean, since high school, and that's a couple decades ago.
And you're still loving it then, is it? Would you ever go back to the laptop again, do you think?
I have a laptop. I have a laptop that I like a lot, a little tiny light thing that I carry around. But yeah, I think I'll probably always have a custom PC at my desk.
You mentioned that, you know, you blog a lot, and you do this yearly NAS giveaway, and I'm just wondering, kind of like, what was the idea behind that? Is it for your learning? Is it just to be nice, you know, to give it away free? What's kind of your thinking behind that? Well,
the second time I did the annual DIY NAS blog, you know, the first time I did it, it was, hey, here's what I built. This is why I built it. And then it got real popular. And then, you know, because it's PC hardware, it got to be obsolete within a year, or it felt obsolete. You know, I had bought older hardware when I put it together, and people were asking, said, hey, what would you do if you were going to do it again? And I said, okay, well, here's what I would do if I had to do it over again. And I gave everybody a list of parts. And then, to my embarrassment, those parts didn't work together very well. I mean, there was I can't remember if it was the memory. There was something. It was really embarrassing. I was ashamed that happened. And after that, I said, well, I'm not going to let that happen again. I'm just going to build this hardware every time. And then I realized, well, I'm going to have a new NAS, at least once a year. And I actually do a different, more economy-friendly NAS build suggestion also. So I do 2 different NAS builds a year, and my storage needs aren't increasing that much that I can justify upgrading my NAS that frequently. So I figured I would just do an experiment and see how, a little giveaway raffle would work for driving traffic to my blog. And it's worked out really well to the point where it's a really good marketing tool. So I like being able to build it. I have it here, and then giving it away to the readers is a fun thing to do.
Absolutely. And you've got it's like a time lapse and also the actual version of you on YouTube actually building it and things. And I think it allows people to see kind of who don't really do much, PC builds or server builds and things, how this all fits together and provides them with a base to actually work from.
Yeah.
So you've got your desktop builds and then your gaming builds and rigs like that. And then you've got your server. And I'm just thinking, what are the key differences then between them when you're making the decisions on hardware?
The driving factor that I always try and put into it is, what your bang for your buck is going to be. What's the most cost-effective way to get your server put together? And I guess the real secret in that is kind of understanding your own needs. And once you're able to, really refine what it is that you want, going out and finding hardware that matches up with that, you can save a ton of money. So, with regards to how I picked out my particular hardware, I had come across, well, I guess I'm getting off on a tangent a little bit. I've got 2 servers here. I've got my network attached storage box, and then I also have my little home lab machine. And the home lab,
which is by no means little.
Yeah, no, it's not little at all. And this is where I was going with cost effective. I wound up finding an article, somebody else's blog post somewhere, saying that you could get these, formerly top of the line Xeon CPUs. They're older. I mean, they're 2 or 3 versions old, but they're fantastic little CPUs, and there's a ton of dual socket motherboards that you can put them in for. I mean, you could get the CPUs used for like $40 to $50 each. And so I saw that article and I said, well, that sounds neat. I want to build a box like that. And that's how I wound up doing. And it wound up being, extremely cost effective for the number of cores, 16 total. I paid like $80 in CPUs. It's pretty incredible.
So kind of like breaking out then, so looking at these considerations and stuff and looking at each of the individual pieces, it'll be really interesting to see maybe in both your setups where you've got your home lab and also then in the actual NAS builds that you do, the driving factors, because what it feels like is it is case by case basis. And that's probably one of the nicest things about it is that you have a different story for each build. There's different requirements. Like I suppose in a NAS build, you're looking for as much storage, as much SATA ports as you can, as opposed to maybe like, in a performance build where you're looking for the fact of maybe having dual socket CPU usage and things like that.
Yeah.
In the NAS build that you've currently made, you actually used an integrated CPU. So I was just wondering, what was the reasoning behind that?
So, yeah, when I built my very first NAS, what I wanted to do was build something that was power efficient, and then also something that was small, like as small a footprint as I possibly can, because I'm putting it here, within arm's reach at my desk, and my desk is always a mess. I would like it all to be infinitely cleaner, and I'd like the computers to take up as little room as possible. And my driving factor on the NAS builds has always been to find, a low power, preferably passively cooled CPU. And it just so happens that all of those CPUs anymore are integrated into the motherboard. And that's how I went that route. If there was a low power CPU that, fit in your regular CPU socket, I probably would be considering it also. I like the integrated motherboards, and, in all honesty, when it comes time to upgrade your CPU, you're probably going to wind up moving up to a newer generation CPU, which is going to require a different socket anyways. So chances are you're not going to get to do the little drop-in-place CPU that goes in the motherboard that you already have. So the con of, an integrated CPU is that it is what it is. If you want to upgrade the CPU, you wind up upgrading the motherboard. But I'd almost argue that that's going to be the case 9 times out of 10.
It's that whole thing of upgrading or like preparing for an upgrade that you may never do.
Yeah.
And it's the fact, as you say, like, and I guess another pro with being integrated is it smaller size. I guess that they can, put it onto the chip easier, better, and it saves space in that way as well.
Yeah.
And like you mentioned, it's passively cooled. What do you mean by that?
There's a heat sink and there's no fan. So that was my big fans fail and fans make noise. So I wanted it to be quiet also. And if there's no CPU fan, that's just one, there's a few decibels right there that it's not going to be constantly generating.
So in both your builds then, was it a requirement to have the sound to be as minimal as possible, fan use, or was it mainly just specific on the NAS side?
Yeah, that would be mostly on the NAS side. Those Xeon CPUs in that home lab server, they're going to require, actual real CPU cooling. There's a couple great big CPU coolers in that box.
Have you ever looked into like water cooling?
I have. I think there's a lot of probably marketing and waste in all of the PC cooling. The concept of water cooling, I think, is really cool. I think it's neat that people do it. I think that it's neat that people can use it to overclock their CPUs to ridiculous levels. I would rather spend that money that that water cooling setup would require and just buy faster hardware sooner or at the time that I bought it. That's just my thoughts.
Wow, that's interesting. And there's another thing that was interesting about the motherboard that you picked for the NAS this time around as well, and it's IPMI.
Yeah,
I'm just wondering what is IPMI?
IPMI, I can't remember what it's not like a TCP/IP, but that's what I think. It's basically it's a management interface over IP. You can punch, when you boot up the motherboard it doesn't even have to boot up. It's working all the time. You can just punch in the IP in your browser and you get a little management interface for the motherboard. You can power it on or off. You can update the BIOS. You can boot it up, go into the BIOS settings, make changes.
All without having to plug in a monitor or anything like that,
yeah,
I'm guessing.
Literally the only thing that I plugged a monitor in for this year was to find out what the IP was of that interface. And then I did all of the rest of the setup of the BIOS. I did all the burn-in testing. I did all of that through my web browser at my desktop PC. It was pretty cool.
I can imagine, yeah, that must be a really nice win to be able to not have to worry about setting out, especially with a NAS where you do just want it to be headless and on its own and out the way.
Exactly.
And yeah, so you go from the motherboards, and I suppose the motherboards, there's many different sizes of motherboard as well. And I'm guessing like with the NAS one, then it was the idea to be very small. And then what about, what size did you go for then with your actual home lab build?
My home lab build is a full ATX motherboard. There aren't any mini ITX dual Xeon motherboards. I don't know if it's a lack of space or just these motherboards go into great big server cases most of the time anyways, so that size isn't a consideration for a server rack like it might be a consideration for Brian's desk space.
Absolutely. And you mentioned that it's actually dual CPU then. So typically in all our hardware now, like we know cores and we know cores and threads and we think, oh yeah, I've got a 4-core CPU. But when you're talking about cores and then you're talking about CPU, you're talking about actually having 2 separate CPUs on the same motherboard.
Yeah, there are 2 CPUs on that motherboard, each of which have 8 cores.
That is insane. Does it work in parallel? Is it a similar build to how the cores would be running in just a single CPU?
Yeah.
And that they'll be shared? Can you split between them?
I think all of that happens behind the scenes by the motherboard's architecture or the operating system that handles that.
Cool. So from that then, we've got the motherboard, and now it's the actual RAM. And one thing that I've been noticing on my kind of exploration into looking into CPUs and for servers and stuff is the difference between ECC RAM and non-ECC RAM. And I'm just wondering, could you maybe explain what the kind of differences are and the pros and cons of each?
Well, ECC RAM, it used to be that all RAM was ECC RAM. There's a 10th chip on it that does parity checking and basically making sure that what's in the memory is what's supposed to be in there. Just about all of your enterprise-grade hardware is going to have ECC RAM in it. Well, there are 2 cons on ECC RAM, and that's going to be cost. The RAM itself, there's a 10th chip on it, so the RAM itself is usually about 10% more expensive. Where the sneaky costs come in are, the motherboards that support it. I mean, you're talking enterprise-grade hardware, so you're talking enterprise-grade price tags. Non-ECC RAM doesn't have that 10th chip. It's a little bit cheaper. It's not doing that error checking and correcting, so it's also a little bit faster. I don't think anybody would really notice it, but a benchmark would show it. And if you have one of those bit flips, that's just what's going to happen. That's what's going to get, whatever the CPU is doing at that time with that memory, that's what's going to get used. So your NAS worst case scenario is it happens to be writing a key piece of file system data, then a bit flips, and you lose a whole storage array or something like that. There is, especially within the FreeNAS community, there is a little bit of zealotry going on with ECC. I am not the hugest proponent of one or the other. I think that using non-ECC RAM is absolutely fine. I think that, for all of us home users, it's not going to make a lick of difference to us. But there are people within the FreeNAS community and other places that say, you can't have enterprise grade stuff without ECC RAM. And I guess my position on all of it would be that ECC RAM is clearly the better choice. It's safer. You give up a little bit in performance and you give up a lot in cost, but what you get is the best technology and RAM that you can. My position is that, the cost, the premium that you get doesn't quantify those benefits. It seems a bit out of whack. I'd rather, if you're worried about losing all of your NAS data, I would rather say, well, use some of that money that you would have spent on ECC hardware and come up with an offsite backup solution. Because one of the things that ECC RAM's not going to protect you from is yourself. If you go and you delete all of your files, ECC RAM's not going to save you from that. And maybe instead of spending money on ECC RAM, you could also spend money on something that'll protect you from that 1 in a trillion bit flip, and also maybe protect you from yourself. An offsite, some cloud storage, or even an external hard drive that you give to a buddy and he gives you his, and you keep a copy of your backup data offsite somewhere. I think that's an incredibly more effective way to spend those same dollars.
Because I suppose the thing is, obviously, it's the whole geographical problem of, well, it's fine that you've got this ECC RAM, but then what happens if the actual location that your hard drives are based suddenly goes up in flames or something, sadly, and you've lost everything anyway?
Exactly.
So it is that kind of working out what is the best bang for your buck. And so from that then, so we then go into the CPUs. And actually, this was one of my first questions. Like when I first got back into it, I was like, okay, well, back in the day, it was Intel versus AMD. Still is, I suppose, but, Intel has really kind of won out. And I'm right in thinking that Intel has dominating now the market.
Yeah, and AMD has been quiet until recently. AMD just released a new set of CPUs, and they look really interesting, and they seem to be a good cost for performance. But yeah, in the last few years, and certainly since I started building NAS machines, it's been all Intel.
Wow. I mean, it was sad because they were like the leaders in like 64-bit architecture, weren't they, at the beginning? Crazy to think. And then they just got overthrown. And yeah, so from that then, you've got the Intel and the Intel I series versus the Xeons. There was a lot, again, when I was starting to look online, and there's a lot of conjecture with this as well, where people are saying, hey, even in you're better off even in desktop hardware using a Xeon in some instances and stuff like that. And I'm just wondering, what are the key differences then for someone who's just looking at these for, they want to look into, they assume maybe that a server, you want a Xeon then, or is a certain an I series chip good enough?
And in all of this, I would say your cost per performance is what should be driving you. Any brand new Xeon chip, they're going to be really expensive. Depending on your I series CPU, some of those are also going to be expensive. I don't have a real preference towards either, other than measuring out what it is that you think you need. For network attached storage, I mean that's a fancy file server. It's not going to need incredibly powerful processing capability. I mean, you don't need a ton of CPU. But what most people are doing are they might want to store a bunch of files and host a Plex instance. Well, transcoding video requires CPU. I mean, you really got to kind of measure, well, what am I going to be doing with this?
And with that then, so how do you work out that? So say, you've got like an idea in mind of like, say you want to be able to do transcoding and things like that. And what type of websites or benchmarks do you kind of rely heavily on for that kind of decision?
So with Plex specifically, you can punch in how much CPU do I need, and they'll give you a equivalent score from the Passmark website.
So with that then also is the debate from more cores versus clock speed. And Moore's law happened, and we eventually were not, we've slowed down the ability per CPU, per core, to be able to get as much out of them as possible. And now we're kind of expanding horizontally instead of vertically. Am I right in thinking different workloads, different processes require different, different concepts of like more cores versus clock speed? And like, is it, very much based on the kind of your use case?
Yeah, it's definitely going to be your use case that drives whether you need more cores versus a higher clock speed. Something like video transcoding, I think that's single-threaded, so you're going to want a faster core. Now, if you're doing multiple streams, that might wind up getting farmed out to each core. Gaming, obviously it requires a faster core. It's single-threaded. Serving up files to a bunch of different users or a bunch of different processes, that's going to be, multiple cores that you're going to be more interested in.
Brilliant. And from that, then we've got the motherboard, we've got the RAM, we've got the CPU, and then it's the storage. And as this is, obviously where the NAS comes in, and this is really what we want. One thing obviously with the Drobo, which kind of helped me and got me away from the fact of having to worry about it too much, was the concept of what they have is beyond RAID. And really, it's like a RAID setup, which you don't really have to worry about too much. With that, then obviously you lose, a lot of control out of it. And I'm just wondering, what actually then is RAID? And there's many different forms of it. So it'd be really great maybe if we could go into a couple of those as well.
RAID it stands for Redundant Array of Inexpensive, or sometimes people say independent disks. So essentially what it's doing is it's taking a bunch of hard drives and then treating them all as one. To the user, it's presented as a single drive, effectively. But then within that drive, the data is written to the disks differently and in different ways so that you have your data spread across numerous drives. So depending on how it's set up, you could survive a drive failure or two or more in order and still not lose any data whatsoever. And in addition to the redundancy aspects of that, then there's an advantage in read and write speeds in that you've got different parts of data on different disks, and you can access that, in parallel together a little bit faster than if all of that data was all on a single disk and it had to go find all of that data to present it back to the CPU. I think your most popular forms of RAID are probably going to be RAID 0. You hear a lot about. That's striping. That's really fast, but it's really dangerous because there's no redundancy. So if you have a 4-drive array and you have a movie file, that movie is split up between those 4 different disks, and reading and writing to it is as fast as it's much faster than just one single disk. But losing any one of those disks at all means you've lost the file. You've lost the entire array. Usually you don't see a whole lot of people do this. I did this once in a home computer of mine years ago, and I can't remember if I ever had a drive fail, and it wound up biting me in the butt. I don't think that it did, but it should have. It was a bad idea. RAID 1 is mirroring, so if you had 2 drives in a RAID 1 array, everything that you wrote to one drive would be also written to the other, which meant that you could, literally go in there and unplug a drive and you wouldn't lose any bit of data. Another common one is RAID 0 plus 1, which is combining both of those. So you do RAID 0 plus 1 across 4 disks where I'm going to get this backwards, I'm sure of it, where you're striping 2 drives and then you're mirroring that to another set of 2 drives. So then you could lose one of those drives and be okay and repair the array. But if you could lose 2, but it would have to be the perfect 2. So if you lost the wrong 2, you'd lose the whole array. And then there are more complex versions of RAID, which are safer and probably a much better way to go for a NAS build these days. RAID 5 effectively puts all of your data across 4 of the drives, and you can survive up to 1 drive failure. So depending on the size of your array. So if you have 7 drives in there, you could lose 1 of those 7 drives and be okay. So your data is written in 2 places on at least 2 of the disks all of the time. If you do a little bit of Googling on RAID 5, there are some articles out there about how RAID 5 is dead, and that there's some scary. We're getting to the size of drives now where it's almost certain that you're going to have a problem rebuilding that array, and that might result in data loss. I think some people still use RAID 5. I'm kind of the NAS guy. I'll say I think RAID 5 is a bad idea, and I probably wouldn't suggest it. My favorite is actually RAID 6, which is a lot like RAID 5, except you have 2 drives worth of parity. So if you have 6 drives, you could lose 2 of those drives before you were in real danger. And that kind of just gives you a nicer, warmer, and fuzzier feeling about your data.
And am I right in thinking that, because it feels that say in the cases of like you got RAID 5, then RAID 6, is RAID 6 maybe subtly less performant than RAID 5 because of the fact it has to be written to 2 disks?
I would bet you that if you looked at the benchmarks that RAID 6 is, you pay for performance with more redundancy. I think that's probably a pretty good rule of thumb for all of computing. The safer it is, the slower it goes.
But the less time you're going to be crying after the fact where you've lost everything.
Yeah, this is a good point.
So you've got then RAID 6, and you mentioned ZFS. What exactly then is ZFS?
So ZFS is the file system. ZFS is a file system, and it's the file system behind FreeNAS. It is a copy-on-write file system, which means you write your data to your storage once, and then the next time you write it again, it reads it all from disk, and it writes it with your modifications somewhere else. And then it checks what you just wrote to disk against the original, and it does a checksum to see if it's still valid. And then, depending on other factors like redundancy, it can also correct for anything that goes wrong, because you do have what happens on disks. It's called bit rot. I mean, eventually drives they go bad, they stop performing, and the data that's on the drive gets corrupted. And what ZFS does, it's really cool, is it can checksum that, and it can correct, based off of your parity data, it can correct some of those errors and protect your data. And another benefit of ZFS is because it's copy on write, it's keeping older versions of your files around, not directly accessible, but it's got features to do snapshots of that data without consuming a whole lot of your storage in the process. That's a really neat feature that saved me on a few times because I've done something silly accidentally. I've deleted files. Yeah, oh shoot, I didn't mean to do that. I need to go back. And you just go into, if you've got them set up to take snapshots, you just go into a snapshot and restore that snapshot, and you've got that file back, the way it was before you goofed it up.
That's cool. So would the RAID and then ZFS be, obviously they're very good companions, but can they be used on their own? Can you use RAID without ZFS?
There are probably any number of ways to implement RAID without ZFS. There are like hardware controllers that do the RAID on the hardware above whatever the operating system does. That they call it fake RAID, where they build software RAID into motherboards. And then there's software RAID, which ZFS does. One of the things that the ZFS tells you not to do is to use hardware RAID and ZFS at the same time, because you can affect it negatively. So yeah, with ZFS, you leave all of the redundancy up to ZFS. It manages all of it, which I find preferable. I think especially for, the home DIY NAS builder person, if you bought a hardware RAID controller and your hardware RAID controller failed, then you very likely need to find that exact same RAID card to replace it. They're real particular. Whereas software RAID, you kind of get rid of that abstraction and you just throw whatever at it, and the software is already handling all of it. Now, there's probably a performance hit to that, having the CPU doing effectively what the hardware was doing before. But I think the other benefits of ZFS far outweigh, what you're giving up in performance on an actual hardware RAID controller.
Oh, that's interesting. And then, so from there, then we've got the storage and we've got the CPU, RAM, and motherboard. And then it's actually where do we put all this stuff? It's the actual casing around it. And that's another big, consideration that you need to think of if you're looking into making a server. Got the concept of racks and then towers. And then also, in the case of maybe your NAS, you've got a smaller kind of tower-based sized box. And I'm just wondering, what's your experience with all these? Like, have you ever gone down the rack route and had like a cool server-ish, in quotes, definitely server-ish looking, boxes and things like that?
No, I don't. I can't remember what job it was that I was working at, but one of my very first IT jobs, I wound up working in a place, and one of the server admins had a rack mount server that he was diagnosing or getting spun up to put into the rack, and he turned it on, and from across the room, it sounded like a jet engine taking off. And that is literally what a lot of that hardware sounds. It's not designed to be quiet. It's not designed to, take up as little room as possible. They're dense, but they're arranged vertically. A server rack is 19 inches wide, and sometimes they're up to about, 3 feet deep. So, that's about the size of a closet that you would have to dedicate in floor space wise. My wife she'd never go for that. I'd never even try to subject her to the noise and the space of an actual server rack machine. I'm very much a proponent for find as compact a case as possible and tuck it away somewhere that you don't have to see it. And hopefully you have something like IPMI so you never have to go and actually touch it.
Cool. And I suppose, so both your builds then are tower-based?
They're both, I guess, what you would call desktop cases, kind of consumer designed to be sitting on your desk next to you.
From there, actually powering all this, and really with a server, then you go from being a commodity home use laptop home use PC, desktop, which is on maybe probably a couple of hours a day, whatever usage you have, to really now it's 24/7, always on technology, and dealing with powering that and then cooling that. What are the kind of key considerations with that?
That's one of the reasons that I like the passively cooled low power CPUs. Since it's on 24/7, your power consumption's a sneaky cost. I've done the math a couple times, and it usually works out, over the long haul that, you pay a premium for low power, passively cooled hardware, but that premium winds up repaying itself over the lifespan of, your utility costs. And that, especially, I live somewhere where our utility costs are extremely low. Other places in the world, your utility costs are not nearly as low as ours, and that comes into a much bigger deciding factor. For the actual choosing of power supplies, I don't put a whole lot of effort into that. On the NAS builds, you've got an idea from your CPU's TDP, the wattage that assigned to the TDP. It's not quite equivalent to power consumption, but it's pretty close. And then usually I throw in 10 or 15 watts per hard drive in the machine, and then I look for a power supply that'll work under that particular wattage. If you had grandiose schemes to add more and more hard drives down the road, I would probably recommend that you size your power supply at the beginning to your maximum number of drives in the future.
In the blog post that you've posted for your latest one, that you already knew what PSU you were going to use based on the fact that it fit well into the case that you wanted. So it's that kind of working out exactly where, case build, like what size it needs to be and things like that is a big consideration.
Yeah, exactly. The case that I picked, that the DS380, uses an SFX power supply. And what I found in buying those is that different people have different interpretations of that standard. So I had bought in 2015, I had bought the same case, and I wound up going through a couple different power supplies that said they would fit, but then didn't wind up fitting. And going with the particular power supply that I chose this year, I knew in advance that it would work with that case.
Being a standard, you would have hoped there would have been a standard size. And with that then, the operating system. You mentioned FreeNAS before, actually, and that's a BSD operating system. And then obviously you've got Linux. And I'm just wondering, do you mind like maybe explaining kind of the differences between BSD versus Linux and kind of the decisions behind using something like FreeNAS over just like an Ubuntu server install?
The entire reason that I picked FreeNAS was because of its web user interface for managing the server. I am not, by any stretch of the imagination, an expert on either BSD or Linux in any form or fashion. I've been almost strictly a Windows guy, and because of that is why I picked FreeNAS.
Looking at the web browser interface and stuff, it feels like a really nice environment to work in and to like manage your server from.
It is. It's very nice. In fact, everything that I describe in the blog is all done from the user interface, except for the initial setup. You press enter a couple times, it tells you what its IP is. You punch that into a browser, and everything from that point on gets done through there.
You mentioned there the IPs then, so the networking. Going through your blog, so I started off looking at networking here, and then like some of your other experiments that you've been doing with your faster than gigabit networks and stuff like that. And I've got to say, yes, they are very, very interesting technologies you've been playing with. What kind of networking things, especially in NASs, do you pay close attention to?
I am pretty much a networking neophyte. I don't know very much about it other than, plug your computer into your little router and hopefully, you get a connection between the two. That was part of my interest in building out my faster than gigabit network. I wound up going to eBay and looking around for inexpensive gigabit or faster network equipment that was secondhand to see if I could get a 10 gigabit link between my primary desktop and the NAS. I had some luck. There's inexpensive stuff, I guess trending towards obsolescence, but it works just fine, and it wound up being really inexpensive. I don't really think that most people need it. Your gigabit network, that's going to be just about as fast as your average consumer hard drive. It'll be able to fully utilize that gigabit link, and you're going to get performance as you would out of a physical hard drive. I don't necessarily think that anybody else needs to do it, but it's certainly something to do that you can go to work and you can brag about and impress your IT guys.
Oh, absolutely. With your actual server setups and stuff, one of the interesting things you do after you've actually built it and you've booted up and everything is stress testing the hardware. I'm just wondering kind of what software and tools do you use to do such a thing?
The first thing I usually do is I use memtest to test the RAM. And basically what it does is it writes patterns to RAM, it reads them from RAM, and what it's looking for are those kind of errors that ECC would catch. And you primarily see those in defective RAM. Every stick of RAM that I've ever had that was bad came to me bad from the shop. But there's also, I guess it's also possible that RAM would fail over time. So, you could periodically do this, but all you do with memtest is you fire it up, it writes patterns to RAM, it reads it from RAM, it takes a while to run, and I usually do at least 3 passes. But if you can do 3 passes without any errors, then you should feel pretty confident in the quality of the RAM that you've put in your machine. And then after that, I usually do a series of CPU burn-in tests to kind of put the CPU under load and really stress everything out, because that's where you're going to find your defective hardware, or if you're buying secondhand hardware, you might find out the reason that this is on the secondhand market. All it does is it makes the CPU work really hard, and it works hard. It generates a lot of heat, and I usually kind of run a few tests. I get meaner and nastier as it goes along. Mostly, I'm just trying to see if it survives. If 5 minutes later I'm back at a blinking prompt, everything's worked just great. And then after you pass the 5-minute test, you get like a 15-minute test. And after the 15-minute test, maybe get an hour-long test. And then maybe after the hour-long test, maybe a 4-hour one. But by that point, I think you're getting pretty mean and nasty. You're putting the server, you're putting the hardware through stuff that you're probably not going to put it through at your house. If it was an enterprise environment, maybe, a different set of criteria of what exactly is mean enough and nasty enough. But I would think for those for my uses at least, I've never pegged a CPU for more than 4 hours doing something.
Yeah, because that is just really, really mean. And the last thing actually I'd really like to talk to you about actually is I'm a fellow coffee lover, and one of the things, the blogs that you post that is about you're experimenting with, what is it, nitrogenated cold brew? What brought this on? And yeah, would you mind explaining kind of the story behind it?
Well, I joined a makerspace here in the area, and one of their members is a guy who does homebrew beer. We've got a homebrew program. Every quarter we meet and we brew beer, and I too like beer, and I got into it, and I built a whole kegerator. I've got, taps of beer on tap. Because of that, I wanted to be able to do nitrogenated beers, a lot like Guinness. Guinness, most beers are carbonated. They inject CO2 in them, and that's the gas that's in the beer. But in Guinness, they use nitrogen, and that's an entirely different experience. CO2 tends to be a little acidic and bitter, and nitrogen is not. And I decided that in the event that we ever brewed a beer like a Guinness, I wanted to be able to serve it under pressure from nitrogen. And my buddy Pat said that, people do cold brew coffee and serve it nitrogenated the same way. And the very first time I started loading beers up, I didn't have anything to put in that nitrogenated tap. I had one tap that was unused waiting for a beer. And he said, we should buy a whole bunch of coffee and cold brew it and then serve it under pressure from the nitrogen and see how it is. And it turned out really fantastic. Under the high pressure, you get a head on the coffee that's a lot like the head on a beer. It's almost like the crema in an espresso or a latte, and it's a really cool mouthfeel. And then, as you know, cold brew coffee is less bitter than your regular hot coffee because the heat brings out some of that bitterness out of coffee. So it's real smooth. It's cold. It works great here in Texas because the summers are unbearably hot. When you leave the house and it's already 80 degrees outside, you don't maybe want to take a hot coffee with you into work. You take a cold coffee instead. It is really nice.
Yeah, I can imagine that is the last thing you want in that kind of weather.
Yeah. I know people who say that hot coffee cools you off, and I think those people are absolutely insane.
Oh man, well yeah, thank you again so much, Brian, for coming on the show. We definitely have to do this again if you're up for it, because it's just super interesting, kind of looking into this different world and the exploration and stuff, hardware wise, and all these different projects you've been working on.
It's a lot of fun. I'm glad that I got to share it with you guys.
Awesome. Well, audience, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.